So this is part 2 hyperbolas, and I have an example here. So it's y plus 1 squared divided by 9 minus x minus 3 squared divided by 25 is equal to 1. And in the previous lesson I did go over a problem which was not necessarily in the standard form. However, you know that this is in the standard form A because you see the subtraction sign indicating yes that this is a hyperbola, right? A type of conic that is a hyperbola, and then you see that there's 1 here again. So this 1 clearly indicates that this is in the standard form. Again, if this was like 500, you would be dividing this expression by 500 and this whatever you had here by 500 to get that 1. So we already have our standard form given to us. So now when we graph, first you always want to really just know the characteristics of this hyperbola. So you know that this is the center will be 3 comma negative 1, right? And that's the center, because you know that you don't want to mess this up by saying this it's negative 1 comma 3, obviously, because you know obviously it's 3 comma negative 1. So that's your center. Same thing, h comma k, that is your center. And now you're looking at the vertices, right? And the same concept, your vertices, your co-vertices, and then your foci, really. So those are the characteristics that we're looking at here. And so, when again, we first want to graph it, I guess. I think it's always easier. So we have our axis here, right? Now we know our center is somewhere here. It's 3 comma negative 1, right? And we know that this y is here. Therefore, we, as I said before, that when you're looking at a hyperbola, if you know that the y plus 1 square is before it's the first term, then obviously you know that this is a vertical hyperbola. It's a vertical hyperbola. And you know that this is a square and this is b square, right? In this case, you'll be surprised to see that a is 3, b is 5, and a is less than b. And it doesn't really matter because, as I said, for hyperbola, a could be less than or greater than b. It doesn't really matter. That only, the rule of a being greater than b, that's only applicable for ellipses. So here we have a vertical hyperbola. So we know this is our center. And now when we look at this, we know 9, right? 9 is a square, right? So therefore we know that our a value must be 3 and our b value must be 5. And so the fact that we have a vertical hyperbola, right? We are really looking more towards like our main vertices, right? Will be guided towards that vertical direction because we have that because it's a vertical hyperbola. Because you know that y plus 1 square is portrayed as the first term, right? X minus 3 square is the second term. So that's what we know here. So now when we find the vertices, right? So we know this is 3 comma negative 1. And we know a is 3, so we're really going 3 units up above, right? And so that puts us somewhere, so if we go 3 units above, that would be 3 comma 2. 3 comma 2. Similarly, we would be going 3 units below, right? And that would be put us somewhere here. That would be 3 comma negative 4. And our vertices here are 3 comma 2 and 3 comma negative 4. Again, these are the vertices because we are looking more towards the vertical direction because it is a vertical hyperbola. So therefore, these are our primary vertices. And now looking at our you could say box that's here, again, this could be larger. This is definitely larger indeed from this side, right? But that doesn't matter. It's still classified as a vertical hyperbola because you know that the y plus 1 square is the first term here. And so we are looking at this, right? We know b is 5, therefore we're moving 5 units here. So we get something here that's going to be 8 comma negative 1. And similarly, when we're looking at 5 units this direction, we have negative 2, right? We have negative 2 comma 1, negative 2 or negative 2 comma negative 1, actually, sorry, yeah, because we're looking 5 units towards this direction, so we have negative 2 comma negative 1. So we have our points here, right? And this makes sense because these are our points, and this is the center, obviously. And so when we're thinking about this, right, when we're looking at this, so we can really connect our box, because this is our box, right? The idea of a box when we're graphing a hyperbola. So this is something like that looks like our box. And so when I always say that these are your vertices, right? And your co-vertices are obviously 8 comma negative 1, right? 8 comma negative 1, and then you have negative 2 comma negative 1, right? So this is important because your vertices are the main vertices. Now when you graph this, you see that this is a good sketch of a box, right? You connected all those points. Now when you're actually making your graph or your hyperbola, you always want to make sure that the diagonals of this box are your asymptotes, and that's important to understand. So when we make the diagonals and we extend those like this, we have to understand that those are asymptotes. Your graph is not going to touch those asymptotes, right? And so when I say that these are co-vertices, that these are not the main vertices, although they're much longer, you have to understand that these are your main vertices, and therefore when you draw your graph, it's going to look something like that. Something like that. And this one will be something like this. So you don't have anything here, because if you had a graph here or a curve that went from here or here, then that would indicate that this is a horizontal rather than a vertical, right? This one is a vertical hyperbola, therefore it makes sense that one curve is here and one curve is here. So that's why that's a vertical hyperbola. Now we're missing the foci, right? And again, if you remember from the previous lesson, again, that formula is a squared plus b squared is equal to c squared. And so looking at this, we already know a squared is 9. We know b squared is 25. You add those, you get 34. C squared is 34. Therefore, c is the square root of 34. Now you know this, and you know that this is the distance from the center, right? It's the distance from the center to your foci, basically, on both sides. And this one will be extending further. It's going to be away from the box. It will, instead of being inside the box, it's outside the box. And so when we find our foci, really, you have to understand that it's 3, right? We have 3 comma negative 1. And so we're really, our foci will be 3 comma negative 1 plus minus root 34. And this means that you have your negative 1 here, right? And you're really drawing, you're really adding that root 34 and you're subtracting that root 34, and so your foci will be somewhere here and somewhere here. Again, it's going to be outside the box, but it is in that vertical direction, obviously, because again, this shape here is a vertical hyperbola. Now if this x minus 3 was here, then the situation would have been reversed. You would have seen a graph that would be here, here, your foci would be here, here, rather than here, here. So this is being a vertical hyperbola changes the foci, changes the curve. It's all positioned in a vertical manner. So your foci will be somewhere here, right? And if you recall the definition, right? The definition of a hyperbola is a set of all points in the plane, the difference of whose distances from two distinct points, which could be the foci, is a positive constant. So that's how we define the hyperbola as well. So again, you should look over hyperbolas and ellipses, and really don't have to memorize the formulas. Just understand the idea of a squared is equal to b squared plus c squared is applicable for ellipses, and then a squared plus b squared is equal to c squared is more applicable for hyperbolas, and how the foci and the vertices, right, they play different roles. And also be careful when you have a vertical hyperbola or a horizontal hyperbola, or you have a horizontal ellipse or you have a vertical ellipse. So thanks for watching, and that is I guess the main ideas that you will be seeing for hyperbolas and ellipses. So thanks for watching.